Good day, Junior Techies. This is Mr. Lodge, and in this video we will be looking at the atom, the building block of all matter. Now everything around us is made up of atoms. If we look at the food that we eat, if we look at our bodies, if we look at the tables, if we look at the chairs we sit on, if we look at the stars in the sky, they are all made up of atoms. Now, these atoms are so tiny that it's very difficult for us to realize that they exist. Let's have a look at how tiny these atoms actually are. Let's consider for a moment a little speck of salt, 1 grain of salt. In 1 grain of salt, if we look at it underneath the most powerful microscopes that we've got, it looks something like this. And in that tiny grain of salt, there are 3 million trillion atoms. That's a mighty big number. Another illustration is a sheet of paper. Let's have a look at the thickness of 1 sheet of paper. If we measure the thickness of 1 sheet of paper, just 1 sheet, the thickness is equivalent to 1 million atoms. So there's 1 million atoms in 1 sheet of paper. So across the thickness of the sheet of paper, like this, we have got 1 million atoms. That also gives us an indication of how small an atom actually is. Let's turn our attention now to the elements. Now, an element is a substance that is made up of the same kind of atoms. If we consider copper, let's look at a piece of copper. It could be a copper wire or a copper sheet. It's made up of atoms. Now, every atom inside the copper is identical to the other atoms. So every element is made up of atoms which are identical to each other. On the other hand, if we look at lead, lead is also an element. It's made up of atoms, but the atoms of the lead are different to the atoms of the copper. Now, the lead atoms are all identical to each other, and the copper atoms are identical to each other. So every element is made up of a certain type of atom which is unique to it. This brings us to a table which is one of the most important tools that scientists have. It is known as the periodic table of the elements. In the periodic table, we list all of the known elements in a particular sequence according to their properties. Starting off with the lightest and smallest element, we have hydrogen in the top left-hand side, and we work our way down to the bottom right-hand side over here. There are over 100 elements known to man, and each one of them is unique. Now, in order to keep things simple, every element has got a symbol. So let's consider an element X, Y. The first letter is always a capital. So that's the capital X. The second letter is always a small case letter. Now, we draw the atom of that element by means of a little circle. This circle refers to one atom of the element XY. Now there's no element XY, I'm just using that as an example. XY would refer to the atom, but it could also refer to the substance at large. It could refer to a bulk of the atoms of the element. For example, we could have the element gold. Gold would have the symbol AU, capital A, little u, and we could draw one atom of gold with a little circle, or we could be referring to a bar of gold, which would be a big block of gold like that. Now you will need to learn the first 20 elements off by heart and their symbols, as well as a few others. We're going to finish today's video discussing something even smaller than an atom. These things that are smaller than an atom are known as subatomic particles. Sub meaning smaller particles of the atom. Now, the atom, if we look at it from a distance, it looks like a little ball, as we've discussed. But at the heart of that little ball, at the center of it, is a nucleus. And that nucleus is very, very small compared to the whole atom, and it carries the whole mass of the atom, so it's very dense. So as we see over here, we've got the nucleus, which is situated at the center of the atom. Let's have a look at the subatomic particles. There are 3 of them. Firstly, in the nucleus, and most importantly, we have got the proton. The protons are in the nucleus, and the number of protons gives the atom its particular identity. Along with the protons, in the nucleus itself are the neutrons. The neutrons don't have any charge. They only contribute to the mass of the atom. And lastly, on the outside of the atom, filling up most of the space around it, around the nucleus, are the electrons. Now the electrons carry a negative charge. Now the reason that the whole atom is neutral is that the number of protons is equal to the number of electrons. If the number of protons and the number of electrons are the same, then the 2 charges, the positive charge and the negative charge, they cancel each other out, leaving us with a neutral atom. Junior Tuckies, thank you so much for watching this video. Please look out for the next video where we'll be looking at elements, compounds, and mixtures. See you next time.